Area of a parallelogram is modulus of A cross B, that is the magnitude of cross product of the two vectors. 1 2-mark question, 2 3-mark question. So no questions from part D and part E. So overall you can expect 10 marks from vector algebra. When two vectors are collinear or when they are parallel to each other, their x, y, z components will be in proportion. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are revising the chapter Vector Algebra. Let's see the weightage of marks from this chapter. So in Vector Algebra, you will be having 2 multiple choice questions, 1 2-mark question, 2 3-mark question. So no questions from part D and part E. So overall you can expect 10 marks from vector algebra. So let's take few objective type of question. A unit vector in the direction of a vector, vector A equals 2i plus 3j plus k is option A 2i plus 3j plus k over root 14 minus 2i plus 3j plus k over root 14, 2i plus 3j plus k over root 6 minus 2i plus 3j plus k over root 6. Suppose we have any vector, that is vector A. Then unit vector A cap is given by vector A divided by its magnitude. So magnitude is nothing but the length of the vector, which will be equal to the square root of the x, y and z square, the sum of x square plus y square plus z square. So if I calculate the magnitude of this vector, that is magnitude of vector A, then it is 2 square plus 3 square plus 1 square under the square root. So whose value is equal to root 14. So it is always vector A divided by magnitude A. So now vector A is here 2i plus 3j plus k over root 14. Hence option A is the correct answer. Next, the value of lambda for which the vectors 2i minus 3j plus 4k and minus 4i plus lambda j minus 8k are collinear is 3, 6, minus 3 and minus 6. So here, when two vectors are collinear or when they are parallel to each other, their x, y, z components will be in proportion. So if so, then here 2 divided by minus 4 should be equal to minus 3 divided by lambda. That should be equal to 4 divided by minus 8. So this is equal to some constant k. And what is that constant? Clearly we can see 4 by minus 8 is minus half. So if we equate minus 3 by lambda to minus half and cross multiplying this, we will get lambda is equal to 6. Hence option B is right. Next, the angle between two vectors A and B with magnitudes 1 and 2 respectively and A dot B is equal to 1 is. Since the dot product of the vector is given, we are finding the cosine of the angle between the vectors. Options are pi by 6, pi by 4, pi by 3, pi by 2. We know that cos theta is equal to A dot B divided by magnitude of A, magnitude of B. A dot B is given as 1, magnitude of A is 1 and magnitude of B is 2. So 1 into 2 is 1 by 2. So theta is equal to cos inverse of 1 by 2. So whose value will be equal to pi by 3. Therefore, option C is right. Next, the value of I dot j cross k plus j dot I cross k plus k dot I cross j is 0, minus 1, 1, 3. So we know the vector product of the unit vector component, that is I cross j is nothing but k and j cross k is nothing but I and k cross I is nothing but j. So it's in anti-clockwise direction. If suppose we move like this, in clockwise direction if we move, then the sign changes. That is I cross k is minus j, k cross j is minus I and j cross I is minus k. So when we move in clockwise direction, the sign changes here. So if we use that here, we will get I dot, so j cross k we'll get it as I. Next we have plus j dot I cross k. I cross k is in clockwise direction, so therefore it should be minus j plus k dot. Next we have I cross j. So I cross j is k cap. Again in dot product, the dot product of the same unit vector whose value should be equal to 1. So therefore I dot I is 1, j dot j is 1, but since we have minus here it is minus 1, k dot k is 1. So plus 1 minus 1 cancels, the value is 1. So option C is the correct answer. Next, if theta is the angle between any two vectors, vector A and vector B, then A dot B is equal to A cross B, then theta is equal to, so that is the dot product of vectors is equal to the cross product of vectors, which means cos theta is equal to sin theta. So we can also write this in the form of tan theta is equal to 1 or theta is equal to tan inverse 1. For what values of theta will get tan as 1? For pi by 4, that is 45 degree. So options are given here as 0, pi by 4, pi by 2 and pi. Hence option B is the right answer. Next we'll move on to 2 marks questions. If vector A is a unit vector such that vector x minus vector A, vector x plus vector A is equal to 8. Find magnitude of vector S. When we say the magnitude, it is always the length of the vector and it should be positive. So if I apply A minus B, A plus B formula here, so this becomes magnitude of x whole square minus magnitude of A whole square is equal to 8. In the question they have given A is a unit vector, then its magnitude will be equal to 1. So magnitude of x square minus 1 is equal to 8 here. So magnitude of x square is equal to 9. So square root of 9 will give you 3. Hence magnitude of vector S is 3. Next question. Find the area of a parallelogram whose adjacent sides are given by vector A 3i plus j plus 4k and b I minus j plus k. So we know that area of a parallelogram is modulus of A cross B, that is the magnitude of cross product of the two vectors. So first let us find what is A cross B. So A cross B we can find using the determinants method. So I'll write the first row as I, j, k. The values here is 3, 1, 4, 1, minus 1, 1. So let's calculate this. I, 1 ones are 1 minus 4 becomes plus 4 minus j. So 3 ones are 3 minus 4 ones are 4 plus k. So if we delete the row and column, 3 into minus 1 minus 3 minus 1 into 1 1. So 5i. So minus of minus becomes plus j and minus 4k. So this is our cross product A cross B. Now let's take the magnitude of A cross B. So this is the area of the parallelogram. So this can be written as square root of 5 square plus 1 square plus minus 4 whole square. So which is 25 plus 1 26, 26 plus 16. So that is root 42. So since it is area, we can use square units. So this is the required area of the parallelogram. Next, if magnitude of A plus B is equal to magnitude of A minus B, prove that vector A and vector B are perpendicular. So using this equation, let me square it on both sides. Then I'll get this in the form of A plus B whole square here. And here this is in the form of A minus B whole square. So if I apply the identities, standard identities, then here it is A square plus B square plus 2A dot B. Similarly here A square plus B square minus 2A dot B. We can cancel A square and B square on both sides. So if we shift here, then it is 4A dot B is equal to 0, or clearly A dot B is equal to 0 because 4 is not equal to 0. Obviously, A dot B should be equal to 0. Now, when we say that the two vectors are perpendicular when the dot product is 0. So, clearly, we can say here vector A is perpendicular to vector B. Next, find the position vector of a point R which divides the line joining two points P and Q whose position vectors are I plus 2j minus k and minus I plus j plus k respectively in the ratio 2:1 internally, externally. So, when it comes to the internal, then vector R is given by MB plus NA divided by M plus N. So, what happens here? Vector R is equal to, the ratio is given as 2:1. So, 2 into vector B. So, when I multiply 2 into vector B, it is minus 2I plus 2J plus 2K plus N into vector A, N is 1. So, this is I plus 2J minus K whole divided by M plus 1 is 3. So, now after adding the components, so minus 2I plus I is minus I, 2J plus 2J is 4J, 2K minus K is K whole divided by 3. So, this is the position vector when the point divides the line segment in the internal ratio. Now, let's come to the external, that is second one. So, here the formula is vector R is equal to MB minus NA divided by M minus N. Clearly, M minus N is 1, that is 2 minus 1 is 1. Now, MB again, that is minus 2I plus 2J plus 2K minus I minus 2J plus K whole divided by 1. So, if we solve this, minus 2I minus I is minus 3I plus 2J minus 2J get cancels, 2K plus K is 3K. So, this is vector R in case of external division. Find the projection of vector I plus 3J plus 7K on the vector 7I minus J plus K. So, let us consider this as vector A and this as vector B. So, projection of vector A on vector B, that is small p, is given by A dot B divided by magnitude of vector B. So, A dot B means the product of x components, y components and z components. So, that is 1 into 7, clearly this is 1 into 7, 7 plus 3 into minus 1, minus 3 plus 7 into 1, 7 whole divided by, so magnitude of vector B, so that is 7 square plus minus 1 whole square plus 1 square. So, clearly this is 14 minus 3, 11. So, 49, 50, 51, root 51. So, next we will move on to 3 mark questions. Find a unit vector perpendicular to each of the vector A plus vector B and vector A minus vector B, where vector A is I, J, K and B is I plus 2J plus 3K. So, let us find A plus B. So, adding these two vector, I plus I, 2I, J plus 2J, 3J, K plus 3K, 4K. And let us find vector A minus vector B. I minus I, 0, J minus 2J, minus J, K minus 3K, minus 2K. So, now here we will take the cross product of these vectors, that is A plus B cross A minus B. So, we know that A cap is always vector A by its magnitude. So, first we need to find the vector which is perpendicular to both vectors. That means we need to take the cross product of these two vectors divided by its magnitude. So, let me consider this as vector C. So, vector C is nothing but cross product of these two vectors. So, here I have again I, J, K and components 2, 3, 4. Here it is 0 because there is no I component. Minus 1, minus 2. So let's take the cross product of these two vectors. I into minus 6 plus 4. Minus j into. So minus 4 minus 0. Plus k into minus 2 minus 0. So here I will get minus 2i, minus into minus plus 4j and minus 2k. So now let's take the magnitude of this vector c. So square root of minus 2 whole square plus 4 square plus minus 2 whole square. So 4 plus 16 plus 4, which is root 24. So now I need c cap. So that is vector c divided by magnitude of vector c. And here root 24 can also be written in the form of 2 root 6 because it is 4 6 are 24 and 4 can be taken out. So it is 2 root 6. Now here vector c is minus 2i plus 4j minus 2k whole divided by 2 root 6. So therefore c cap, when you divide each term by 2 root 6, I will get minus 1 by root 6i plus 2 by root 6j minus 1 by root 6k. So this is the unit vector perpendicular to both vector a plus b and vector a minus b. Next question. If two vectors, vector a and vector b, such that magnitude of vector a is 2, magnitude of vector b is 3 and a dot b is equal to 4, then find magnitude of vector a minus vector b. So let's take square of this vector, magnitude of vector a minus vector b. Then I can express this in the form of a square plus b square minus 2a dot b. So this is given here, a minus b whole square. So this is 2, 2 square is 4. This is 3, 3 square is 9 minus 2 into 4 because a dot b is 4, 2 4s are 8. So a minus b whole square is, so 9 minus 8 is 1 plus 4 is 5. So a minus b is equal to root 5. Next question. Three vectors, vector a, vector b, vector c, satisfy the condition that vector a plus vector b plus vector c is null vector. Evaluate mu is equal to a dot b plus b dot c plus c dot a if magnitude of a is 1, magnitude of b is 4 and magnitude of c is equal to 0. Since the condition is given in the form of a plus b plus c is equal to 0, so let's take the square of vector a plus vector b plus vector c whole square. So now using the standard identity in algebra, so we can write this in the form of a square plus b square and plus c square plus 2 times a dot b plus b dot c plus c dot a. So now here a dot b plus b dot c plus c dot a can be replaced with mu and this is 0 given. So 0 is equal to a is given 1, so 1 square is 1, b is given as 4, 4 square is 16 and c is given as 2, so plus 4 plus 2 into mu. Now we have 16 plus 4 plus 1 which is 21. So 21 plus 2 mu is equal to 0 or 2 mu is equal to minus 21 or mu is equal to minus 21 by 2. Show that the position vector of the point P which divides the line joining points A and B having position vectors, vector A and vector B internally in the ratio m is to n is m into vector B plus n into vector A divided by m plus n. So this is section formula important for 3 marks again here. So here we are dividing the ratio for internal division. So let me consider a line AB here. So let O be the position vector, then OA is vector A, OB is vector B. Let P be any point on the line segment AB, which divides them internally in the ratio m is to n. Then let us consider this OP as vector R. Now we need to show that vector R is MB plus NA divided by M plus N. Now according to this, clearly from the diagram, AP divided by PB is equal to M by N. Since they are vectors, we'll represent this through vectors. Now AP using the position vector can be written in the form of OP minus OA whole divided by, here PB can be written as OB minus OP. Here we have M by N. Clearly from the diagram, OP is vector R, OA is vector A, OB is vector B. So here we have R minus A divided by B minus R is equal to M by N. So let's cross multiply this. NR minus NA is equal to MB minus MR. So let me shift the second terms on both sides towards the left hand side as well as right hand side. So then I'll get the equation as MR plus NR is equal to MB plus NA. Or if you take R as a common factor here, R M plus N is equal to MB plus NA. Or vector R is equal to MB plus NA divided by M plus N. So this is the vector of the point P. Next question. Find the sine of the angle between the vectors I plus 2j plus 3k and 3i plus 2j plus 6k. So we know that sine theta is given by modulus of A cross B divided by magnitude of A and magnitude of B. So according to the formula, first let's find what is A cross B. So A cross B is equal to I, J, K. And second row 1, 2, 3. Third row is 3, 2, 6. So let's evaluate this. I into 12 minus 6 minus J into 6 minus 9 plus K into 2 minus 6. So we have here 6i minus 3j, minus into minus plus, and here we have minus 4k. So let's take the magnitude of A cross B. So 36 plus 9 plus 16 under the square root. So we're getting this value as root 61. Now let's calculate magnitude of vector A. So magnitude of vector A is nothing but square root of 1 square 1, 2 square 4, 3 square 9. So which is root 14. And let's calculate magnitude of vector B. So magnitude of vector B means 3 square plus 2 square plus 6 square. So which is 9 plus 4 plus 36. So which is root 49 whose value is 7. Now sine theta is equal to, so A cross B, magnitude of A cross B root 61 divided by, so root 14 into 7. So or theta can be written as sine inverse of root 61 divided by 7 root 14. So this is the sine angle or theta value, that is sine inverse of root 61 divided by 7 root 14. So these are all very important few questions which you can expect for your final examination. So we'll meet you in the next session with the new chapter. Until then, keep watching, keep learning and keep exploring. Thank you.